Hello everyone, this is Yamini Parepalli and my roll number is 20BQ1804I8 and I am from ECEC. Now let's discuss about dielectrics. A dielectric material is electrons bound to the nucleus of the atom. No free electrons are present in the dielectric molecule. Electrical conductivity is very low for dielectric materials. Conductivity of the ideal dielectric material is zero. Dielectric materials are mostly non-metallic. Negative temperature or coefficient of resistance is present for dielectrics. Dielectric materials are generally classified into nonpolar molecules and polar molecules. Nonpolar molecules are in which the center of gravity of positive coincides with the center of gravity of negative charge. They are symmetrical in structure. Zero they have zero electric dipole moment. Here you can see the picture of the non-polar molecule. And now let's see polar molecules. Center of gravity of positive charge and that of the negative charge are separated by a finite distance. This means that the center of gravity of positive charge and center of gravity of the negative charge are at some distance, and they are not coinciding as in non-polar molecules. So since they are not coinciding, they'll have non-symmetrical structure. They have permanent dipole movement. The dipole moment is not zero. Now let's see some properties related to dielectrics. First one is electric dipole moment. It is represented by mu. The product of charge and distance between two charges is called electric dipole moment, which is called mu is equals to q into r. See here in the diagram, the two charges, positive charge and my negative charge, are separated at a finite distance r, and the charges are same. If it is plus q and this must be also minus q. If this is plus 2q and this also must be minus 2q, and the charges must be same. Its units are coulomb meter or debye. And the next property is electrical susceptibility, and it's represented by psi symbol xi. The electric susceptibility xi is defined as the ratio of polarization vector to the applied electric field E. Xi is equals to alpha by E is the formula of it. Now let's see what is polarization. Dipole moment per unit volume is known as polarization, that is alpha is equals to mu by V, and its units are coulomb per meter square. Here mainly the polarization have four processes. I mean those four processes are electronic polarization, ionic polarization, orientation polarization, and space charge polarization. Now let's see each polarization one by one into depth. Electronic polarization. Here electronic polarization, as the name suggests, it is due to the electrons. Here when an electric field is applied, positive charge displaces in the direction of field and electron cloud displaces in the opposite direction. Polarization means there is a displacement or some change in the direction. So the positive charges are moving towards the direction of a field, and the electron cloud is moving opposite to the direction of the field. So mu is directly proportional to the applied electric field. It is independent of temperature. This electronic polarization is independent of temperature. And here the sigma is called the charge density. Charge density is equals to charge by volume is a very known formula. Here charge is minus Ze. Here Z is the atomic number and the volume is 4 by 3 pi r cube. Here volume, we are taking the volume of a circle because an atom is present in a circular form. So sigma is equal to minus Ze by 4 by 3 pi r cube. Now we will see QE. For QE, for each electron we will see the charge. QE is equal to sigma into 4 by 3 pi x cube. Here x is the charge displaced, how much distance it displaced. Here by substituting some formulas, by substituting the sigma above we will get Q is equals to minus Ze into x cube. Since in an atom it is influenced by an electric field, Coulombic forces will come into existence. So the Coulombic force formula is equals to 1 by 4 pi epsilon naught into Q into Qp by x square. Here QE, we know that QE is equals to minus Ze x cube by r cube from the above equation, and The positive charge is Ze. Here we will not mention minus because the charge of the proton is E into the atomic number, and by x square, and by solving this result we'll get Fc is equals to minus z square e square x by 4 pi epsilon naught r cube. We'll mention it as equation 2. In an atom, to maintain the equilibrium, the forces, the Coulombic force and the Lorentz force must be equal. Here Lorentz force is Zee, QE, that is Zee. Now here if Coulombic force and Lorentz force are equal, we get alpha E is equals to 4 pi epsilon naught r cube. By this we complete the electronic polarization. Now let's see into ionic polarization. When an electric field is applied to the molecule, positive ions are displaced by x1 and negative ions are displaced by x2. So here two displacements are happening. One is positive charge and negative charge. So what will be the resultant displacement? Actual formula of the dipole moment is mu is equal to q into r. That is, r is the distance displaced. But here positive charge and negative charge, there are two ions displacing. So the resultant dipole moment will be mu is equals to q of x1 plus x2. Now here F is equals to E into E. Here F is equals to m omega naught square x, since the ions move with angular frequency omega naught. Now here by equating E equal to m omega naught square x, and by solving we get x1 is equals to E small e into capital E by m omega naught square x. Similarly x2 is equals to small e into capital E by capital M omega naught square x. Here small m and the capital M are the mass of anion and cation respectively. Now by adding x1 plus x2 and by taking common, we get x1 plus x2 is equals to small e into capital E by m omega naught square into 1 by m plus 1 by m. Here we know that mu is equals to E into x1 plus x2 and mu by E is equals to x1 plus x2. So mu by E is equals to E square omega naught square into 1 by small m plus 1 by capital M. So by finally, since polarization is the dipole moment by electric field, we get ionic polarization as E square omega naught square into 1 by small m plus 1 by capital M here. Now next let's see orientation polarization. Here orientation polarization is in the space. P naught is equals to n into mu bar into orientation. It is a constant and its value is n into mu square orientation into E by 3 kT, where K is the Boltzmann constant and T is the absolute temperature. And by solving it we get alpha naught is equals to mu square orientation by 3 kT. After finally the total polarization is equals to polarization due to electrons plus polarization due to ions plus polarization due to orientation and polarization due to space, but since it is 0 I didn't mention it here. So finally alpha equals to 4 pi epsilon naught r cube plus E square omega naught square into 1 by small m plus 1 by capital M plus mu square orientation by 3 kT. Now let's see internal fields or local fields. Local field or internal field in a dielectric is the space and time average of the electric field intensity acting on a particular molecule is the dielectric material. Evolution of internal field. Consider a dielectric placed between two plates. See, here is the dielectric placed between these two plates, parallel plate capacitor, and let there be an imaginary spherical cavity. So we are taking a spherical cavity. Around it are the positive and the negative charges. Now we will see field E1. Field E1 is the field intensity at A due to the charge density on the plates. See, the charge density is on the plates. This plus minus place around the cavity. So that E1 is equals to D by epsilon naught and D epsilon naught E plus P. E1 is equals to, and by solving we get E1 equal to E plus P by epsilon naught. We will mention it as 1. And the field E2 is the intensity at A due to charge density induced on the two sides of the dielectric plates. see, due to these charge plates, and it is equals to minus p by epsilon naught, and we'll mention it as equation 2. And field E3 is the intensity at A due to atoms contained in the cavity. We are assuming a cubic structure, so I mean inside the quantity, so it is 0. Now next we will see field E4 due to polarized charges on the surface of the spherical cavity. This is on the surface of the spherical cavity. So to solve it, if I am taking a small area dA equal to 2 pi pq into qr. By solving it, we get dA is equal to 2 pi r square into sin theta d theta, where dA is the surface area between theta and theta plus d theta. Here I am taking a small angle of dr and d theta, and I mean that dA is the total angle between theta and d theta. And now the field due to E4 is 1 by 4 pi epsilon naught into dq by r square. The field is theta equal to 0 direction is 1 by 4 pi epsilon naught dq cos theta by r square, and by solving all this we get d e power 4 is equals to p by 2 epsilon naught cos square theta sin theta d theta. Here, the total field E4 due to the charges on the surface cavity is E4 equals to integral 0 to pi dE4. By substituting dE4 and by solving the integration, we get E4 equal to P by 3 epsilon naught. So, the total internal or Lorentz field can be written as EI is equals to E1 plus E2 plus E3 plus E4. And by solving all those, we get E plus P by 3 epsilon naught as the final result. Now let's see into Clausius and Moissanti relation. Consider a dielectric material having cubic structure and assume ionic polarization and orientation polarizability are 0. That is alpha I and alpha O equal to 0. And P is equals to Nu, where EI is E equal to E plus P by 3 epsilon naught. And by just substituting all the formulas, and we get P equal to N alpha E into E by 1 minus N alpha E by 3 epsilon naught. Here we know that P is equals to epsilon naught E into epsilon R minus 1. By equating equation 1 and 2 and by solving, we get N into alpha E by 3 epsilon naught is equals to epsilon R minus 1 by epsilon R plus 2. This is called the Clausius and Moissanti relation. Finally, we have completed the discussion on dielectrics. Thank you.